nasty group.
Savitzer.
Yeah.
He's
Him.
he's in Austria. He works out of Austria. He's highly experienced. He's really sharp. But I think what she means by that, he's often doing. I know he's cladding and glazing, but I think he's maybe heavy into the glazing. Logical is a program by Orgadata, which is basically a library. It's you can work logical works standalone. It's kind of like 2D automation in a way. It's like if we had a counterpart that was only 2D, like HiCAD 2D on steroids, kind of like 3D on steroids, as I like to call it.
Yeah.
Logical will automate curtain wall and windows and doors design. So they have millions and millions of articles of parts in there that can be you can prepare an elevation in Logical, and then I think they can automate some shop drawings and bill of materials, and I think some estimating functions. Now, for glazing, our module for glazing is called metal engineering, which I think that has to do with how it translates. It doesn't make the most sense to me, but metal engineering means glazing to us. And we have a direct two-directional plugin where Logical, you can take that 2D profile from Logical and you can load parts into HiCAD. You can load whole facades into HiCAD, windows, doors, and then we'll take those contours and in the background, the software extrudes it. So it takes a 100% 2D platform, which is what Logical is, and brings it into HiCAD in 3D space, where you can either keep it in 3D space or you can actually make edits in HiCAD, such as holes or, slots or whatever, and you can actually send it back to Logical and the change will be represented. So it's actually pretty neat.
Oh, wow. Yeah, that's pretty cool. And that doesn't really apply to us, but he still has some pretty good content and videos and stuff. I got zoomed in on a part that just seemed like it took forever to zoom out. I was wondering if there was a shortcut. I looked around pretty good. If there was a shortcut to like what AutoCAD has in Zoom Extents, where you just press the button and it'll zoom out and put all your content in
Yeah, that's
one
there.
view.
That's
Where
that's
is
there
that?
in your top, kind of underneath your ribbons in the drawing space. You got kind of those see-through icons. Uh, we call them the transparent toolbar, where you got your views and your representations, and you got the there's a there's an undo, there's a show only active part, hide active part. It's kind of right there in the middle.
Oh, new view process. Oh, no, last model. Can I share my screen?
Yeah, sure. I'm still starting up here, or else I'd
Okay.
jump right in. Yeah. So left, 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 left,
I thought
left.
maybe it would be one of
There it
these
is.
view. I thought it would
That's
be
it.
that one.
That's it.
How did I do? Okay, so I'm zoomed in and I want to zoom out. Well, it's working now. Or maybe I
And
was stuck in
that is
another
also
command
linked
or
to the
something.
home key on your keyboard. So the system shortcut for this is home.
Okay, I got you. Yeah. So I feel a little bit better this week than I have in other weeks, but I really wanted to get to this. Now, I did I was able to watch your video that you sent, the panel repair that you made. That was very informative. Um, wasn't
Which
able to
one?
follow along.
Which video?
Uh, you had sent me a video called panel repair. Remember when I screwed that panel up and you were showing me how to fix it?
Oh, yeah.
Yeah. And that was really cool. I downloaded it for future reference. And I like the SharePoint viewer. You're able to slow it down, but not too much by point eight, play it at point eight speed. Whereas like I think YouTube's got 0.5, 0.25, and it's just
Hmm.
too slow, you know.
Are you able to download them, or does it not let you?
Yeah, I was able to download it. I have
Okay.
it as an MP4
Yeah.
panel repair.
Depending on your MP4 player, I've been using VLC media player forever and ever and ever.
Me too.
In
I
which
don't have
case
any
you can
license
also
fees.
fine tune the speed there. Um, I don't know if you
Okay.
use that function in VLC, but
Used to,
I
well, I don't really watch a whole lot anymore these days, but
well I don't either. Believe it or not, I switched from Windows Media Player to VLC way back in college when I would download you know bootleg movies on
hmm
on Kazaa or whatever the one
back
was
in
at the
the
time.
day.
Eventually, I went to IRC, but um, and then you needed something to play it because Windows Media Player wouldn't do it. Yeah, you could download codecs and
Right.
install all these different ones, but then VLC seemed to just have all that
Yeah.
right out of the box, so to
Yeah.
speak.
From what I understand, it's still the standard. Um, I have it installed at home, and it's still my default player at home, but I just don't watch enough
Yeah, I understand. I'm
anymore
always
these
messing with
days.
videos here, either making them for somebody or somebody has a problem. They send me a video. Um,
Yeah.
happens
I need to
fair
learn to
enough.
do that. I should learn to do that.
What? Make a video?
Yeah.
Oh, you should have on your computer. There's a free one in Windows, but I think you have to like bump it up to the next paid level to make videos, greater than a certain file size or
Uh,
length or something. But
certain
there
quality.
are plenty of free ones. I have one called OBS Studio. Um, I'm still trying to think of what the Windows one is. Video.
Is it just like a screen recorder?
It's the video editor, right? Windows video editor.
Probably video editor.
Yeah, I think I remember using that back in high school.
Oh, Clipchamp. Clipchamp is a Windows app that you probably already have. Um, you can
I
make
just
short
thought,
videos with it, um, which might be good enough for you. The problem is if I need to edit like an entire training video, then this free one's not going to cut it. Uh,
uh,
but yeah, OBS actually that is a free, which can do various. I don't know. It was recommended. We also have Camtasia. But the licenses they're Germany's licenses, and so they actually told us, hey, you can use it for now, but if we ever run out of licenses, we're gonna be asking you to surrender that. So I was like, all right,
okay, good to know. I will 100% look into that.
sure. I'm trying to remember what was the last thing we did on Friday.
Um,
Finished up the regular 4-sided panel. What we did, top flaps.
Okay, we did 24. Well, you had sent the file.
This is cladding day 4. Did I send the video from Friday? Maybe I didn't.
I think you did. No.
Okay. That makes sense because I can't find it in my files either. And usually when I send it to you, I add it to my files at the very same time. Let's fix that real quick. So at least you have it.
Where did we leave off? I don't recall. I recall being really interested in that, in this thing right here,
Right.
and how to create that. We were talking about that as opposed to going with just straight 90s and using this or something like this for the future, which I was in favor of because we could go with a 90 essentially with this, but this is much more adjustable for
Correct.
other purposes.
And what I see people do is they'll they'll build the the rectangular panel, and they put a lot of time into it. They build it for production. It looks good, and then at a certain moment they go, "Hey, what if I want this thing to do, not squares and rectangles?" I said, "Oh, that's very possible, but fortunately, you got to start all over." And they don't usually respond too well to that. Sorry, that's the way it works. But okay, do you have some? Did you start it? Did you run into some problems or what?
No, I don't think I have it open. Here's my no. I do a lot of starts and stops, and I don't save them. But it was just a rudimentary of that shape.
Mm-hmm. Did we
that
do
you're
it?
Looking at.
Did we study it for like a 3 or 5-sided shape first? Or we didn't?
No.
I don't think we got to that. Let's start there. Let's start a little simpler. To
Okay.
to learn it in a little smaller context, because it's absolutely the same concept, whether it's 3-sided, whether it's a 3-sided panel or a 20-sided panel, which I've never seen anybody do, but by the way, it's the exact same concept. It just obviously gets the concept is replicated over and over again until you get the number of sides. So the last thing that we did before was just working on a basic panel with maybe a standard return.
We were trying to get the edges to cooperate, and that was when you said, which that other guy didn't do, by the way. I'm still going to go with your advice because it makes more sense to do, parallel first. Do a top and a bottom before doing the two edges. I noticed in that guy, Michael, gosh darn it, Sabitzer. Yeah. In his example of that, he did not do that, but he's also working some with logical. So
Which video are you watching? Because Logical makes me think he was doing curtain walls or unitized facades or something like that.
It would be in my history here. It would be one of these.
Oh, okay.
It doesn't always say it right in. Well, there's an
Precise-
example.
Precise
he
cutting
doesn't
and unfolding of sheet metal. Okay.
Yeah, he doesn't always. It's not always in the title when he's referencing something from Logical, but I'm still able to get enough, information. Not that I'm going to retain it all, but it's every little bit helps.
Mm-hmm.
So this one,
Plant,
and then I think
planted
ISD group.
piping.
I'm sorry.
No, I was just reading through the topic list here.
I'm gonna come down. This is where I left off at. And he's got quite a bit of content, and so far they've all been shorter, really informative videos, which is pretty good because my attention span is, about this long.
Plus, you
And
might only have 4.5 minutes before the next person appears at your desk to ask the question now.
Yep, that's often the case, yes. But and a lot of it is it's rather intuitive. I find that if you're familiar with some techniques, like halfway familiar with SolidWorks or AutoCAD, a lot of this stuff is
Yeah, having 3D experience helps tremendously.
yeah.
We have the primarily of our customers, often they're just doing kind of cladding like you. They've been doing AutoCAD their whole life for pretty much all design, and coming from 2D to 3D is now this big.
Oh.
It's this big change that, while it's not so complicated in theory, you've got sketches that are extruded in short, and that's pretty much the core basis of 3D modeling. Just turning what you're used to doing in AutoCAD and giving it a distance in or out of the page.
Yeah.
And that's kind of it. But I mean, I had one guy one time, he could barely draw a line, a sketch line, and he's in a training class for like this, what you're doing, with advanced parametrics eventually. And I'm sitting here going, I don't think he's going to make it.
I feel bad for you in that regard. I feel bad for you having to work with me.
Yeah.
Sorry, Robert. I can't imagine that. That must have been tough.
And it was in a class of 3, and was it 3 or 4? I think it was 4 of them in a class, and 3 of them were, just picking it up. And then this, guy, and I mean, I think he was close to retirement age. He'd been doing AutoCAD his whole life. I mean, yeah, okay. So why is this person even being put through this training? But okay, I don't make the list. I only take the people that are given to go through the course. But yeah, it was a little rough there.
How'd you end up doing? You probably retired right away.
Well, it's actually, unfortunately, he was a long-term smoker and older gentleman, and actually he ended up passing away suddenly due to other factors, of course. But
yeah, that'll do it.
All right. So what? Okay, let me ask you. Would you rather learn first how to attach profiles to the panel, the one that we've already been building, and then we move on to like start with a 5-sided maybe to learn that concept? or do you want to go right away into the 5-sided and circle back on attaching profiles and whatnot?
What do you think, Marco?
I say we do the 5-sided one and then learn how to attach them. Once we get that 5-sided one done, we can kind of use that, start using it as our standard, playing around with that. Or with final product.
And then move on to attaching
Yeah.
profiles and
Okay.
Yeah.
okay,
All right. Sounds good.
do that.
So let's go in the same book we've been working with to page 92.
That's right. I've got to split my screen up here. All right, I am with you. I think that would be
Okay. So let's start with creating a situation like this here. We're gonna eyeball it to start. So we're gonna say new, and then a sketch. Let's see. I'm gonna work on the XY. And I'm gonna start off with some axes. Maybe, I don't know, 75 by maybe a little long, but that's okay. And we're gonna make these auxiliary lines or construction lines with this button right here. And we're going to pin these. So this is going to be basically an origin system for what we're about to do.
okay. Would you make it 75 by what?
Like 75 by 80 or something. It doesn't matter so much. Let's see. About 100.
I gotta remember to start at the origin.
Yeah, yeah.
And I didn't follow your pin
Oh, it's
pin
right here.
technique. Okay, how do we employ that?
You just click
It
on the lines.
should it already be fixed? Oh,
Huh?
or not?
Sorry, fix. Pin. I think I'm using SolidWorks term.
You're making it coincident, which is right. Yeah,
Basically, I'm
affixing.
just taking these lines. This is, come on, get off that line. This is coincident to origin just because I snapped to it initially.
Okay.
But this doesn't matter so much really because we're just gonna click this and say fix, fix. And now these lines are basically glued to the current location in a way.
Okay. I ended up making a box, a rectangle. I didn't use the lines. Let me I'll have to catch up.
That's probably fine. Just make it auxiliary, make it construction lines. Or you could just trim the two lines that you don't
Okay.
want.
And then fix. As this action creates constraints between fix. Okay. And okay. And then I need to make them construction lines.
Yep, auxiliary or construction lines. You find that button.
Yeah, I see the button. I just click on the lines and click on the lines. Okay.
Yeah,
Good.
auxiliary button. Click, middle mouse. Done.
I'm gonna
All right.
save this.
Yeah, it's a good idea. Now, if the items that you're working on is auto saving, then it does exist. Remember we retrieved it that one time? Maybe you don't quite remember those steps. We can look at them again, but do you remember those steps, Spirit?
Remember, I could hide my own Easter eggs.
So if you know a drawing saved in the autosave process, you know how it pops up down here every so often. I think it's 20 minutes or 15 minutes. You can change that interval, by the way. Let me show you quickly. Now, if I can only remember where it is, I think it is.
Did you start recording?
I did. I did that as soon as you started asking questions.
Oh, okay.
Data save interval. So it's here, and don't do what I do. I have mine off. That little thing popping up when I'm in the middle of a command drives me absolutely nuts. So I bear the burden of saving on my own. I just, which kind of, at least I've created that habit, my whole life. So if I'm typing a document, I feel like every other keystroke is Control F. If I'm, of course, Word auto saves now, but back in the day, that wasn't the case, as I'm sure you know. Same with HiCAD. You can also work Control F into your, into your modeling, but often enough when I accomplish a certain step, I just come up there and hit save, and I work, and I come up here and hit save. But anyway, that's up to you. But here's where the value, you probably have 15 or 20 minutes or something in there. So you can change that. So that's in system settings and then data save.
Okay.
So if you wanna make that, if you wanna increase that to every 5 minutes to help you keep your work when maybe you're getting up and down from your desk or whatever, maybe that'd be a better situation for you. For me, it just drove me nuts, so I turned it off.
Too bad you couldn't just hide it, put it in the background only. They should have an option for that. They've got an option for everything else, seems like.
Yeah, I guess it depends on how they program the kernel.
Yeah.
All right. So next step is we're just going to eyeball a shape like this. So as long as it's generally speaking, and don't line up any of the points, with each other, if you know what I mean. Don't make them vertically or horizontal aligned. So it's just something like this. So like here, and I'm gonna make this just a little less. Here to here, here to here, to here, to here. Something like that.
Okay.
Right out again? No, granted risk.
This is training number 4.
Yes, for element topics. Marco's floating around the office back there.
Where'd you go, Marco?
He's flickering. He's a hologram.
Ah.
Making my ass some coffee. I'm dragging a little bit.
So you were the way it appeared over here. You're actually like levitating in the window.
Right.
All right. Do you guys have a sketch?
Yep.
Yeah.
Okay. Okay, so we're going to start creating these constraints. So first we're going to do the x's. So we're going to start at ix0, and we're going to relate that from this point to this line, and then we'll do the next one, and so on and so forth. So let's look at the first one. So I'm going to say smart dimension. I'm going to say this point to this line, and I'm going to say ix0 is going to be the variable value, and it's going to propose a value. And here's where You can start with anything, but I like to say something nice and round looking.
What was it? I_X?
I_X0 is the first one.
I got a window popped up. 3D, see edge, HCM scaling. I want to scale complete sketch or only adjust the element.
Only, okay, it's asking you if you want to take the whole sketch and scale it together, or if you only want to change the value that you changed. I tend to say only the element that you're working with right now.
Okay. There we go.
And then continue on with the other one.
Yeah, and we'll work our way around. So the next one's IX1, and then we got IX2, and 3, and then 4. Don't do what I do and skip 2.
Oops. How do I delete one?
A constraint.
Oh, I see it. Got it. I just did what you did.
Okay, you got the X's.
Well,
Skip one, didn't you?
no, I got him. Yeah, I skipped one.
So if you skip one, I would delete it here, but I would also delete the variable, because as soon as you assign another one to that name, it's going to snap to that value that the first one was, and it might throw your sketch. You
All
probably
right,
have no idea what I'm talking about.
Can I share my screen?
Yeah.
So can't
I
change
see.
that to 2.
I would delete both those constraints, the X4 and the X3.
We're gonna do
Okay,
it
and now
again.
so that you see what I'm talking about, try to go ahead and add x2.
Oh, okay.
No. X2 is going to be on the other one. So look at your
We got
points. You're
0,
working
1,
counterclockwise. So you got
2. Oh, so it'll be okay. So we're going around.
you're going
Okay.
counterclockwise. I might have not said that. Okay.
Yeah. I_x2. What'd you have for 2? 72?
Oh, I do, but it doesn't.
Yeah.
You don't have to mimic exactly, just as long as it's the shape generally looks like mine, or the
It's
page of the
easier,
book.
less confusing if I
All right.
if I
Now
just
you
do it
still
like
have
this.
those x3 and x variables. Now let's see what happens when you try to add x3 here. I think it might make a little more sense. Okay, that's pretty
Nothing.
good.
But it
Okay,
didn't
now
ask me for a
because it
variable.
already existed, because you already made the variable. So the
Okay,
variable remains created. What you deleted was the constraint only.
okay. So
And
can
if you
I
want to
add it?
look at the variables you're creating, you can also switch over to the variable list while you're working here.
And I can adjust it there if needed.
Correct.
Okay.
So
So
looks
there's
like you got a little
yeah.
mishap there.
So I can delete that one.
Mm-hmm.
Okay, so we just got one more to do.
All right. So I think this next one's gonna make my point hit home here. So when you add that here, you change that to
I_x.
IX4. Watch
Gonna
what's
be
gonna
4.
happen.
Enter.
See? Because
Yep.
the variable had already been created and assigned an initial value. So that's why I was saying if you skip one, you might want to delete the whole variable before you continue. What I would do here is just hit, either undo or change the value. Yeah, something like that.
Yeah.
Sometimes it changes it in a weird way that's so weird that it's kind of hard to
Yeah. It's better
wrap
just to
your mind
delete the
around
whole.
what values it needs to be.
Gotcha. Okay.
All right. So I think you probably can guess what's next.
Now we gotta go the other way.
Now we're going to do the Y's, and we're still working counterclockwise. So we're going to say this one to here is Y0. And let's go with a 20 here. Same thing for here. Y1. So watch what happens as I finish up here. What color is the sketch changing to?
Green.
And what does green indicate?
Green means go.
Well, that's correct. So all right, we all get to go. Let's all go home.
All right, I gotta go help load a sheet real quick. So be right back.
All right. So a sketch turns green, Barry, means it's fully constrained. No degrees of freedom remain. A sketch that's blue means that some constraints have been created, but not all degrees of freedom have been
Eliminated.
constrained.
Right.
A black sketch means 0 constraints have been created, and a yellow sketch line indicates that it's been fixed, kind of like what we see there. So those are the different colors. So you got black, yellow, blue, and green, all indicating different constraint levels.
Now I need to have my IY0 the same as yours. Do
What do
we
you
need
mean?
to start with the same start point?
Yes, because here's what's going on in the background, Barry. So these are system variables, IY0 and IX, all of these here in the list. And so in the background, to create your base sheet, so you know what's coming here, we're going to use this shape to derive a piece of sheet metal or ACM or whatever. You know, sheet from sketch, you know, is where we're headed here. So when you go to element installation to use this, in the background, it's going to take those sketch lines and it's going to basically measure those lengths in the background and feed them into your variables of your variant of your catalog file, and that's how the panel is going to adapt to that unique shape from the elevation sketch.
All right, I deleted I screwed up on the IY0. I deleted it from the feature, but it's still showing up in the drawing. Do I need to reset the redraw? No. Right.
Let's
I'm
take a
gonna
look.
share my screen. Which one is mine? I think it's this one. So, I created this thinking you started over here.
Mm-hmm.
No, created this and then wanted to undo it because I thought you started it with this one, but I see you started with this one. And so I come over here to the variables and deleted it out of here, but it's still showing up here.
Yeah, that is a little interesting. I don't have a great answer there, but probably even though it appears to be functioning here, I think you would find a problem somewhere down the line. But I would just double click the constraint and you can assign it again. So if you click on the value, so where you got 1 foot 0.52, just double click.
Okay.
IY0, yeah. What's the problem there with IY0, by the way?
Well, I thought nothing.
Okay.
It's just I thought I was starting. That's why I asked you that question. Do I need to start at the same place?
Yeah,
The
answer is yes, because IX0 and IY0 need to refer to the same point.
Yeah. Okay.
Okay, is the variable there?
So, yeah.
There it is.
Okay, so that wasn't terrible.
No, a little strange how it was still showing up. I agree with you, but I don't have a great answer there.
Right. What'd you have for this one?
8. And you understand what I'm doing there, right? It doesn't matter what the value is. I just like to see whole numbers. So I'm just taking it to the nearest a nice sounding number. There's not a whole lot of strategy behind the values that I'm using.
Yeah, I understand, but for my own purposes, it's
okay.
Sometimes helpful to at a glance to see that it's the same. What'd you have for this one? Probably 30.
Which one is this? 2? 48.
I wrote 2 in there. Yep. This one probably 50. I'm guessing.
60 for me, but again, you can use 50.
Right. 160.
Okay.
And one more. And we go from here to here. What is this one?
4. I got 36.
36?
Uh-huh.
Okay.
Now, I don't think, Barry, you had to keep going up to click that smart dimensioning every time. You see how the command remains open there? It's asking you at the bottom left if you wanted to go into another.
Okay.
Anyway, just for just so you know.
Thank you. Yeah, I did figure that out.
Let's see. Not sure if you care, but for IX4, I have 8, you have 3, which again is fine, but I know you're trying to
Okay.
replicate here. There you go. 16, 86, 72, 38, 28, 48, 60, 36. Yep.
Thank you.
Sure. You got it over there, Marco?
Yep.
All right. So, let's see. We need to create this parameter. Okay, so we are going to create this parameter INR. And what does this mean? First off, it needs to be a number. INR is going to be the current number of sides. So this shape here, we've got a 5-sided shape, which means, or up to a 5-sided shape, meaning 3, 4, and 5-sided sheet metal or ACM parts can be created from this sketch. So at the moment, we're going to max that out to the possibilities of this sketch so that we can continue. But INR is the number of edges in this shape. So right now, we want to define for 5. And a little bit later, we'll be actually changing this value a bit to finish up the exercise. So since it's going to be used for a 3, 4, or 5-sided shape, we need to define some statements. And this is nothing more than, again, an if-then statement. We're asking, is INR greater than 3? So is the number of sides greater than 3? If it is, use value IX3. If not, use the value for IX0. So for 3-sided, we want to use 0 because we don't want these 2 extra sides. If we wanted a triangular facade, I know that's maybe a strange thing, but let's just hypothetically say we wanted a 3-sided facade. Same here for the Ys. Then we got down here, is it greater than 4? So do we have a 5-sided shape here? Yes, then we want to use the value for IX4. If the answer is no, we want to use the value for IX0. I remember struggling with the logic behind this. I just kind of went with it and saw that it worked, but the logic is there. Although it's maybe a little bit confusing to think about for the first time. Let's just start putting it in there and we'll see how it works. So for IX3, I'm going to see if copy works here. We want to replace IX3 with this value. So let's find IX3. And I'm going to copy this in there. Make sure it looks okay. Oops. Same thing for the Y's. I have Y3s over here. And same for the 4s. Notice that the shape nor the values are actually changing because right now we have a 5-sided shape.
First, we have to add the I_NR feature or variable.
First add the INR because then you'll run into problems as you paste this in there. It'll tell you variable not found or something like it. It might prompt you for it. Usually here, I like to create it first and then add it.
I want to create first.
So you remember how to add? You just say right click, add variable, and then you can give it, I and R.
And then just a value 5.
Yep, correct.
Okay. All right, we got that. Where'd you get your copy paste from? What document? Is that from the PDF?
On the PDF on page 94.
All right, I see it. IX3. So we're replacing IX3 with the formula right there.
Correct. So you can copy the formula. And then here you're going to find your IX3. For me, it's here. And you can just copy that in there.
do
Maybe
that.
we can't. I was gonna say, too bad we can't just throw it in there on the variables list.
That's what I did.
It's not a variable, it's a constraint.
Right.
So the variables stay the same other than adding the INR. This is the constraint value, not the variable value here.
Right.
Okay.
Can you do that from the features list?
Change the constraint.
Yeah.
You can come down here to HCM.
Let me see where you're at.
HCM.
Oh.
And then all your constraints all the constraints for the active part are then shown. So right now our sketch is, well, the only part, but it's also the active part here. So here, you could do the same here, like you can double click and it pops up. So you can work
Right,
from the model or
That's what I was
from
looking for.
the constraint tab. HCM, it's HiCAD Constraint Manager. So that's kind of you're probably sitting here wondering what the hell is HCM?
Okay.
That's what it stands for.
There it is. Okay. I understand that.
I think I got it.
All right, so we did this, now, as the first corner point of your panel, basically, is to lie exactly in the corresponding corner of the sketch area. The variables x0 and y0 will be set to 0. Why did we not do that from the beginning? I think it was just easier to get this set up, get the constraint set up, not locked onto something. And then here we're going to say IX. This is going to be 0. And this is going to be 0. And this is where it's now going to live. So like what we're doing with our elevations that we've been working on, I know this is just a square panel, but this panel element is starting down here in this corner because we built it on the 0 point for the sketch, or I think in this case we used base from sheet. So in this case, we put that base sheet right on the 0 for the bottom corner. So what we can do now is we're simply going to, let me make sure I'm not skipping ahead here. Nope, now we're going to create a sheet from Sketch. And let's say we pick some kind of material. You can do ACM or sheet metal, whichever you prefer. I'll go with ACM. So now we have a uniquely shaped piece of sheet metal ACM, following the sketch that we just created.
All right, back to the first step again. We need to constrain that to 0, which I think you did in the variables, right? You did
Change your values to 0. Yep.
Yeah, for
Like 0.
IY0 will be 0. And IX0 will be 0. Okay. And then that way, everything from here forward will be fluid, with the exception it will be, that point will always be constrained to the 0. Correct? Yeah.
Yeah. So in the background, these points are going to lock in on that 0 point of your grid square or whatever shape it is. And that 0 point is bottom left there.
Yep. Okay. I am good.
Okay.
The green means
So-
fully constrained.
Say again. Green?
Green means fully constrained.
Correct.
Unlike
Which is what you want in this case, because we don't want to leave any degrees of freedom unconstrained, because that would lead to interesting results when we go to apply the element on elevation. Now you can play around with it a little bit if you want to.
I'll save it.
Here, yeah, that's a good idea. Say, let's say we change this to say 4 sides. You see how that edge went away?
How did you change it?
Just in the variable list.
Oh.
It's going to work in the background when you're using it on the elevation, but for now we're preparing the library part. So that's why we arrange all this here. So
How do I get out of this sketch? Get to your view.
well, did you create a sheet?
No, that's what I didn't do.
So sheet from sketch.
Okay. Delete sketch after creation.
Yes, because the sketch always exists attached to the feature step.
Okay. And how thick did you go with your sheet?
I made it
to
4 millimeter ACM of some sort. I don't remember what color I picked. I'll have
Fix
to show you, of course.
bone white. Our favorite around here. Everything's always bone white.
Which one?
I did the Luca Bond US solid and bone white.
Ah,
I see that color about 3-4 times a year come through here.
All right. Oops. Here we go.
okay. So it's now a sheet metal part, correct?
Yeah.
So what I was showing you is that here you could play around with it a little bit to kind of see how it works. So let's say we want to have a 4-sided shape. Change my INR to 4. And you see that that edge here just disappeared. Did you see how that,
Yeah.
see, there it is.
Okay.
Now it goes away.
But we can't go more than 5. But we
Not in
can
this
go
one.
less than 5.
No, you can't go less than 3. Obviously, you can't have a 2-sided
Right.
surface.
All right. Okay.
Now let's say we go to 3.
Yeah. That's pretty cool.
So what you would do for an 8-sided shape is no different than what we just did. You just got to do those extra steps to account for those extra edges.
Right.
Which is what that document and drawing that I sent you should show.
Yep.
Now, let's say we work a little bit further to make this a little more like a facade. For the sake of time and to show you another feature here, instead of going flange, 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 like we've been doing, which I would do, by the way, if I was making a production part, because of the control that you have, having them all separate. But we also have a from surface here, which is kind of nice because you can say, length, shorten outer, mill. The way this works is you can pick a whole surface and it'll give you flanges from that surface, as well as do some corner work here, all in the same command.
Flanges to surface.
Yeah.
That's right there.
And you pick the top of the sheet for the flanges to go down. If you wanted the flanges to go up, you would then pick the bottom of the sheet.
Similar to when we were making them earlier.
Similar to just the standard add flange
Right.
command that we've been doing.
So, am I looking? From surface, select edges. That would all go. Mine are coming up.
Really? Did you pick the top part of the top surface or the bottom surface?
I did. I picked the top.
You picked the top surface and the flanges are going the wrong way?
Let me share my screen. That one. That's the right screen. Where are we at here? Flange, sheet metal flange from surface. No.
That's creating a new sheet from surface. You see, you want flange from surface. That one right there.
Yeah. So I clicked on this.
Mm-hmm.
That's the top surface. And it looks like, all right, I
They're
was looking
going-
at it wrong.
They're going down. It's just maybe a little bit tricky
Yeah,
to
that's
see.
throwing me off. This. Okay, because it's actually showing it going down, because this has to be the top.
Because there's a
Okay.
0. You see that origin there?
Yep. Okay, I got you. So are we good here?
So let's
And
see.
this-
You can have your go all the way up to the top to set it for all flanges. You could say 1 inch or whatever. 0.79 seems a little strange, but
Like one. We'll
one,
go
and
90
then
degrees.
let's say fitting mode. So yeah, so here you can say mill, and
Oh,
then
yeah.
for fitting mode, you probably want here shorten outer probably.
I think that's what we went with last time.
Mm-hmm.
Shorten the outer.
Now those
And
bottom
then
two ones, bend radius and allowance method, even though they're checked and show values there, they're doing nothing here because you're doing a mill edge zone, which does not use a bend.
We're talking about this.
Does not
Okay,
use
so
a specified bend radius, and your allowance method is actually not used when it's milled ACM.
Right.
So even though they show there and they're checked, they're actually doing nothing here. I point that out because it's misleading, because I get questions on that.
does it hurt to leave them checked?
If you're doing a milled zone, then
Which we will
it
be.
doesn't matter what you do there; those are being ignored by the program.
Okay. Okay.
Because of the situation. Now, it would be nice
Right.
if they grayed out or went away or whatever. Maybe that's a nice suggestion for improvement. So at the bottom here, let's say these are the typical miter. This is what you would see in the corner miter menu.
Right.
So which one looks a little better to you for what you would typically want a corner to look like?
That's a bent miter. This one. I don't know.
They're all pretty messy
Okay.
except for that last one.
Yeah. Probably this one right here looks pretty good.
Yeah. So I would go
Like
with
that
that one. And you notice that now you're now for the joint, you want to find the one that says milled edge. I believe it's the far right.
Yep.
And now it'll allow you to pick that tool from the library. So your preview went away because it doesn't have a tool. So here's
Might
where
be
you can
the
pick
93.
90 or something. And the preview returns.
Look at that.
That's nice.
And
that's a
we
little
allow
clearance
any
value.
chance?
I usually make it 0, but some customers use that clearance to influence the development result in a certain fashion. I say start with 0. Eventually, you're going to do a test cut, right?
Right.
See how it comes out, and let's go from there.
Okay. Okay. Look at that.
Pretty nice command, actually.
Yeah.
It's a little more designed for direct modeling, not so much as the parametrics. It's not that you can't use it for the parametrics, but to do what you're doing, you're going to want that control of flanges made individually. So,
Yeah.
right now I'm showing it to you so you know about the command, but to save a little bit of time, because I want you to learn the concept of creating the sketch here, not so much as learning how to add flanges, because you've already kind of done that.
Yeah. But I like this. I could see us using this quite
Yeah,
frequently.
for like IL panels that just standard returns in the middle, that this thing will speed it up dramatically.
Yeah. I could see us using this probably more than you think, Robert.
Maybe. Well, I'll be happy to see it. And you can expand this here. You do have values here which could be parameterized. Here are each flange on your part here can have here, again, it could also be parameterized with a value, or look here, a formula, meaning a variable. So there are some things you can do.
Yeah.
So it'd be cool to explore that. To be honest with you, I think most people just does, you get some control over this, having them individual.
Right.
The main thing being this feature constraint. So you know how you can type in here, certain conditions. So they're all behaving in the same feature step, which means you don't have that individual feature steps flange to flange. So you lose a little bit of control here. Actually, I feel like you lose a lot of needed control. But there may be some situations where this is great. Occasionally, or probably more often than not, you might have a panel system variant that works for, we'll say 90% of the situations, but sometimes you get to something unique, just model it. Just model it in place in your model and be done with it rather than trying to spend time. I get it. Oh, I want that in my variant so that I can use one part file for all these situations. It's very appealing and I understand, but people will get hung up on that. They spend way more time trying to make it in their variant. Often they might screw something else up that was already working well. And then, just because they want this super duper panel variant, sometimes just model it and be done.
I would like to be at that level.
You will. Okay, so let's come back to our variables, and let's, for example, change this to a four-sided panel and watch what happens.
What's my plan?
Your flanges are going to fail because we just took away an edge that was being used to calculate that feature step.
So
how could we fix that? Well, for the sake of, I think the easiest way for the sake of the exercise is to now say INR equals 5 for these flanges. So a feature condition or a feature constraint is now applied to this feature step. Now that still doesn't help us when we go over here to 4. So let's create another step. And this one is going to be INR equals 4. Now you get flanges when you go to 5
or 4
or 4 or 3.
3. Well, not 3. Oh, there they are.
So we need to add yet a third. So sometimes you need additional steps to create the same thing in a different situation with different conditions because of the parameterization.
All right. So you were adding additional flanges to surface there under your features.
Yeah, I created a separate step for different situations that will occur, such as
Okay.
3-sided, 4-sided, 5-sided.
How do was it a copy? Did you use a copy and then change?
I didn't, I just called up the function
Okay.
again. So here, let's walk through it on your screen.
Okay.
Okay. So your flanges are failing on this 4-sided, but you want them for 5-sided situation, right? The flanges that we see have the little arrow symbol next to them in the feature step. You see the little arrow marker?
This one.
Go up a little bit. You see that little red circle?
Yeah.
You see, hover over it. Action cannot be executed. If you dive down, if you expand your feature step, it'll tell you what the error is. You see how it's an attachment. So expand that. Sometimes you have to dive for it. And this one, and it's probably going to say edge not found or something like that. Okay, unable to find edge. Which makes sense, right? Because we just took away that edge when we switched INR to 4. Now this feature step works great for 5-sided shapes, right? So we obviously don't want to do away with it. So, but we want to create that feature constraint to where INR equals 5. So remember how to add a feature constraint? We were doing it the other day when we were saying connection top versus connection top is 0 versus 1 when we were adding flanges last time.
No. I probably will recall once I'm in the process of it.
You see at the very bottom where it says constraint currently has a value of 1.
Yeah.
So what 1 means build, like execute. What 1 means on. Okay.
Yeah.
So change that field right there to say, for example, INR equals 5, for example.
Oh, well, it,
Oop,
I underscored.
There you go. You can select it.
Yeah, I could select it. Equals, or just 5?
Equals 5.
Equals 5. Okay, so that should.
Okay, so the error goes away. We still don't see the flanges, which is correct because we just constrained this to only work for 5. Now switch your INR value back to 5 for a moment. There they are.
Good. Okay.
So we've got the 5-sided shape covered. Now we need to cover 4-sided and 3-sided.
So basically, you've got additional flanges to surface.
And notice that it shows, notice what it shows in that value field when everything's collapsed. It
5.
it copies that value there so that you don't have to expand everything to see what your feature constraint is. So it's kind of handy that they do that, that it does that.
Yeah. So at this point, we would probably want to copy that down and change it to a 4 and then do another one for a 3. Or
Yeah.
am I
Well, you
missing?
don't copy it. You just add a new. You just add another. But first you want to
Oh.
change it over to 4-sided. So let's make INR 4. Okay.
Okay, now we got
Now
a problem.
Now let's add the appropriate command, which is what we just did a minute ago. Let's just do it again.
So hit this from surface.
Yep, and it probably remembers everything you did the first time, so
Oh,
it
okay.
should be pretty convenient to just select the surface and immediately apply. Should be all that you need to do here.
Select surface. Okay. And now we can change that.
So now what does the value need to be? No, you don't want to change that value.
No, I wanted to copy and paste that.
Oh,
Then
that's okay.
change the value to 4.
That's fine.
That's
You
fine.
can copy paste it.
Copy. Need to highlight that. Paste, and then change that to 4. Now,
Okay.
come down
Good.
here. Now we're good. 1, 2, 3, 4. That'll work. I'll need to do the same thing to 3. So should I keep this at 4?
Nope. You want to change it to the situation that you're working on. So
5 is what we started with. But
well, now
then-
you want to do 3, right?
right. There's 3. Now we just come up here and do that. Select the surface. Hit OK. And then you just change that to 3. Error in formula.
We kept, looks like we didn't delete the 1.
Oh.
Say okay. Let's see what we got. Yeah, the 1's still there. You see it there?
Yep. There we go.
So now this facade can be used for 3 to 5-sided situations. Make sense? Kind of?
Yeah. I'm going to need repetition on that, but yes, that makes sense. Yep. And we got no issues up here. Go back to 5. Deactivated by constraint. Okay. I'm liking those joints. Really cool.
Good. Making sense over there, Marco?
Yep.
Okay. So I know we only have this part, but typically you're going to want all your variables to be up here at the assembly level, because you're probably not going to have just sheet metal or ACM here. You're going to have sheet metal and brackets and screws and all kinds of stuff. So just good habit to go ahead and put this up here. I'm going to switch this over to a regular assembly, just because I feel it's a little more appropriate.
So what did you do?
I'm not sure what it shows on yours. Did you have a main assembly at all, or
No.
or maybe no assembly?
I just have a file and can I share my screen real quick?
Yeah.
Is this is what I've got.
Okay, so you don't have an assembly. So assembly is not required here because we only have one part. But let's say typically you're probably not going to have just one part. You're going to have your ACM, you're going to have your stiffeners, you're going to have your brackets, you're going to have your rivets or whatever. So typically you're going to be in an assembly situation. Just so happens that right now we're not.
Can we create an assembly above it at this point?
Yes, I
Or
think
would we
we
just
follow
start
the
a
good
new-
practice here to go ahead and mimic the realistic situation. Let's just go ahead and create an assembly.
Which would be
You can
how would
right
we
click
do that?
there, and you see it near the top. You got extrude, you got main assembly, and then the third one would be assembly.
Well,
Not down, working over. Yeah, there you go. Assembly. Okay. And you can call that whatever you like. It's just proposing a default there called assembly. Here's where you would probably name the panel system that you have, or whatever.
Okay.
But as long as you understand the
assembly.
concept, you don't need to
Right.
pay too much attention to that right now.
I just set mine to do a main assembly right off the rip, and then I can delete or edit it later.
Yeah, that's from your start.
Yeah, right on the start menu, just have to do a main assembly.
Yeah.
Can I call this main assembly? Would it be the same?
It would still be a regular assembly, but you could call it whatever you wanted there.
Okay.
The article can be your choosing.
Okay. All right, we're good here.
So you have a main assembly there, Marco?
It was a main assembly. I right clicked it, went to assembly part structure, and I deleted the main assembly and turned it into a regular assembly.
Okay, good.
I would like to move this up above here.
You actually want to move the ACM down into the assembly just by dragging and dropping. So there you go. That's more appropriate looking. Now what do you need to do with your variables?
Roll at the top.
Variables look like they're still part of the
part, right?
Oh, yeah. So we want the variables to apply to everything in the assembly and not just the part.
Correct. That 95% of the time, you're going to want them to be assembly level only. Some advanced situations, you may want to have only some under the part, but that's we'll leave that for a long time from now.
It looks like they are under the part.
You want to move them to the assembly. So you remember how to do that?
No. Can I just
Okay,
drag
well,
and drop?
expand them. We need to be able to see them first.
Right.
So select INR, hold Control Shift. Yep. And now just click on any one of them and drag it up to the assembly.
Okay.
That's it.
So
All
now
there is to
it
it.
will apply to anything.
Anything inside of that assembly. So as long as
Right.
the part is in that assembly structure, then the
Right.
variable will apply to it.
So this way we could have several parts, some 2 or some 3, some 4, and some 5 sided, and these will all apply.
As long as
To all
it's
of the-
inside the assembly. Yep.
Right.
All right. So now what do you need to do?
Save.
We have this ready to go.
Save it as an element.
Correct.
Civil, no, layout planning. Save variant for element installation.
Where you
And
seeing
make
that
sure
at?
your assembly is the active part at this
Oop.
very moment.
3D part, yeah. Assembly.
Where you
You
save that
understand?
at?
You understand, Barry? So we want to save this as an element.
It wouldn't be up here as a save
Remember,
as.
it's at the bottom right in the civil engineering bar.
Oh,
But before you do that, we need to make sure assembly is the active part. It probably is, but I don't know for sure. So right now we're looking at the variables list. So let's switch back over to the 3D structure list and see which part is active. So, okay, it was not the active part. So you want to click on the assembly. Now it shows red. Red means active. And now you want to go find that button that we were looking for a second ago. So
where was that?
here, any
Layout.
guesses?
Yeah.
Where?
Yep, layout planning.
That would be this one.
And then that one right there.
I'm probably gonna have to write this step down
Oh, it's
and
running
keep it
green.
here. Huh? Green means good. means it's correct.
That is mine.
So it was make sure assembly is active.
Yep. And that's important because let's say you're making an edit. It's important for the first time you save it, of course, but let's say you're making an edit and you need to save it again. Let's say you accidentally have your ACM part selected instead of the assembly. HiCAD will treat that as a brand new element, not editing an existing element, because it's expecting the assembly part name, not the sheet metal part name.
Right. We're good here. Where was that? That was layout planning.
Okay. Now, the
Then our
GUI.
GUI popped up.
Well, who can tell me why we don't see any variables on the left-hand side here? We just made a whole bunch of variables. Why are they not visible?
Yeah, constrained.
What was that, Marco?
Because they're all constrained.
No, not quite. Any other guesses?
Why are variables not showing up here?
Correct, because we just made how many variables? We did IX0, IX0 through 4, IY0 through 4, INR. We just
bunch of them.
made a whole bunch of them.
Are they not editable variables? They're just either on off.
That's correct. Well, that's close. They're system variables. They work in the background. So system variables are like what you just said, not editable from the element GUI. So only editable variables will appear in the screen on the left. And in a normal situation, we probably would have assigned flange length and whatever else. But right now we're learning the concept. We skip that step for this example, so we don't see anything.
So we have to recreate these variables or reclassify them as editable.
You don't want these as editable. They work in the background. You want it to be automatic.
Okay.
Now how does it
we
know?
Don't want them to. So you're saying we don't want them to show up in this variables list?
Correct. I'm explaining why what's happening is good or correct.
Okay.
Because these are all system variables to work in the background. So the sketch will drive these variables. So when you apply the element to your grid in the background, it's going to be coming up with how many edges are counted, 3, 4, or 5, or whatever. And then it's going to use the IX and IY values that are returned and measured from that sketch. And it's going to feed them in the background into your variable list of this variant. And that's how the shape is going to be correct for that grid area. So it's all happening in the background.
Okay.
Okay. We saved it. I'm going to jump back over to here. And let's see. I believe I sent a file in your training items. Called Pen Sheet.
Under what folder? What was that?
Element installation.
Yeah.
All right. Okay, I got pen sheet. Open that up.
Yeah, open that up, and it's just a unique grid here that we can try this out on without spending time drawing this sketch.
Okay.
Got it.
So let's give it a whirl.
Rating.
Now we don't get a preview. Why do we not have a preview right now?
Element installation.
Waiting on software. What's it waiting on?
I've got the drawing open. I'm showing element installation.
So I called up the panel, at least on my computer. I have it here. This is how I saved it.
I heard mine. Okay.
And remember, we didn't prepare a GUI, so this is going to appear blank. That's correct. But you notice how we don't see, sort of an orangey looking preview of the panel. Does anybody remember why that might be? Right now, it's correct. I'm not expecting a preview because we haven't arranged for it.
Is it not?
It's okay if you don't remember. So remember in your library.
We haven't added it to the catalog.
Your library for this item, we have a preview column in the table.
That's right.
Preview file here is blank. Who remembers what we need to put in this value for the preview to function?
Just the name of the file, right? Just drag and drop.
Yeah, you can just say
Yeah.
copy, paste.
Install. Let's see here. Well,
And Mullets.
Now you guys might need to be careful because you probably saved it both to the same table.
Yeah, that's what I was gonna ask. We'll let Marco do that since he's already on it.
yeah. On the installation.
He can probably fix yours for you.
ISD example.
Okay.
Copy. Paste. And Barry, I think you just called yours assembly. That was last on the list. Copy. Paste. Okay. Save. Saved. Close. All right. Should be in the preview now. Five-sided panel. Barry, yours was just assembly.
And if you don't see a preview because you didn't arrange for it, it's not necessary. You can click OK. It'll still build the parts.
I think I'm doing something wrong. Gotta hit reload.
Yeah, do a reload.
Not seeing a preview.
Did you reload the catalog?
I did. I'm gonna reload it again.
Did Marco, did you hit save on your side in the catalog?
Yeah.
Okay.
Double check. Cat editor closed. Yep.
I am not seeing a preview.
Does yours give a preview, Marco?
No.
No.
No, we
Okay.
saved a picture of it.
So you edited the field here.
Yeah, where's my cat editor? All right. That was in where are we at? Factory
Here.
standards. Install planning element. Install elements. All right, it's the example. Look at the preview file saved in there. Yeah, name and preview file are the same. Could be.
Had you already created the panel?
Yeah. Okay.
Okay. If you've already made it, sometimes when you add the preview file in an element system that you've already created, it can not always generate the preview until you completely start with Sketch, all the way back with Sketch only. It has trouble adjusting after you've created it and you add that entry. Even though you do a reload, sometimes you got to go back to the Sketch level, which is generally only a problem if you're testing it like we're doing now. In general, you're going to prepare your panel systems, add the preview. Basically, I'm saying you're not really going to see that problem unless you're unless you're kind of doing the exercise the way we are.
I remember about my cat editor when I mean, on the drawing, when I adjusted my catalog editor, but let's see, try that again. Standards, where do they go? Five-sided panel.
Want to share your screen, Marco? That help?
Maybe we double check here. All right. Catalog editor. Try it again. Now bring it up to that one. Install. Very. Oh, my preview's coming up now.
All right. I will reload.
So when you save your panel, I don't know, maybe just because I didn't save the panel. I was on the panel drawing when I had to do the catalog.
Really, the best way is to save the panel as element installation, immediately open the catalog,
Yeah.
change your preview, then go to your grid sketch and load the panel. But sometimes we've gotten ahead of ourselves here. We save the panel to element, then we go to the grid, then we load the panel and go, oh shoot, there's no preview. And then we start screwing around with the preview column and trying to save it and sync everything back up. Is kind of the issue.
You're not popping up in preview yet, Barry. You should be good.
It's not showing.
Hmm.
Unless I'm doing something wrong. I'll share my screen. Most of what I got. And I'm going to reload it catalog.
No, hold on. I went to switch drawing first and bring up your panel. What makes a difference? Oh, I went to switch drawing and made sure I was on my panel drawing when I did all the catalog editing. I don't know if that made a difference or not.
No, because you're saving panel to element installation. All it does is creates that part file.
Yeah.
And it automatically creates a table entry for you. But that's all it does. So when you make a table change only, then it has nothing to do with the part file that you previously created. It's just a table. It's just a table change.
All right.
A database change. All right. So Marco promises us that he added the preview and saved it.
All right.
So let's do a reload.
Reload.
Okay, you see how it's spinning a little bit? It's actually reloading information. And sometimes if it happens so fast, then nothing might have really happened. So, okay, you didn't need to click anything. You just needed to go right away and load your panel because all the grid was highlighted.
Oh. So.
Okay, go right away to the catalog button and load your panel. You see how every panel in this grid is already selected.
Yeah.
So as soon as you click on one panel, it now deselects all of them and only selects the one that you clicked on.
Talking about
Just
this
so you know.
preview.
Okay. So whichever one is yours.
Yours is assembly, Barry. You just saved yours.
What did I do?
It says assembly.
But you see what happens when you load, when you try to load a square panel in a unsquare grid, it tells you no.
Okay. So what do I do? Cancel?
No, you just need to load the other panel. Your panel, Mullets, I think, is the square panel that we were working on last time. No,
Looking for that one?
that's what Marco says.
This one.
So you loaded Marco's panel, which is fine, but I would want to know that the panel that you built works.
Which would be,
I don't know what you saved it as. I think Marco said it was called assembly, but again, I don't know. We can check.
that's what I saved. I think it's what I saved mine as.
Okay, then let's load that one. Okay,
That look right?
yeah.
Okay. Yeah, I'm not familiar, but I didn't remember this process.
Okay.
So we're good?
You're good?
Okay. Where'd Marco go? Potty?
Maybe. I don't know. He didn't say.
Hmm.
So here we had one part file applied to all these different sizing situations.
That is really cool. You got one with 3 sides. 5, 4, 5, 5, 5, 4, 5. 1, 3 right in the middle. Hey, it's symmetrical. Look at that. That's pretty
Actually,
cool.
not the easiest sketch to draw. That's why I didn't want to. I just wanted to apply our panel.
Well, it's not quite symmetrical. Looks
Is
symmetrical.
it not?
The top is symmetrical. It looks like it could just be because it's way over there on that side of the screen. It's messing with me. Yeah. You come down the center here and it's not symmetrical. The top looks symmetrical, but these down here are not. It still looks pretty cool.
That's a unique
I
set
find
of panels.
fascinating the polygonal masonry of the mysterious polygonal masonry of the ancients.
The ancients.
Yeah. And we have no clue how that was done today. Yet we're to think they were all primitive.
Yeah, I don't think we're ever going to figure that one out.
All right. They were so primitive we don't understand it. We can't replicate it. Fascinating.
Oh, for sure.
All right, I gotta go potty too.
Yeah, let's take 10 or 15 or whatever
Okay.
here.
Sounds good.
All right, cool.
You're muted. There you go.
I got yours because you have like Teams open on your screen, and I'm seeing a video of a video and it's reversed. Oh, how you doing? I want to show you.
Oh,
Let's see. How do I share?
oh, I gotta stop sharing.
Yeah.
There you go. Oh yeah. Hey, what'd you use?
I don't know. Are you backwards now?
I don't know. I'm normal. You can read that in my hat. Okay. So I'm not backwards. So did you get that fixed?
Yeah.
What'd you use?
I don't know.
P-Edit?
Oh, again, Alpha Cam, geometry, special functions, simplify line segments. And that broke them into like really choppy ass lines. So then after they were simplified, like let's see if I can find one here. So see this one all squiggly still? Yeah. So
Yeah.
geometry, special functions, simplify lines. I think I just went to 0.12. Gonna change that much. Nice and straight. Now it's really super choppy. So then after I didn't like how choppy that was, and then turn that shit to a spline. That's fine without the freaking. I'd like break them up into different chunks
So
and
it
stuff.
didn't
That
change.
one. Now it's a nice fluid curve, but it doesn't like splines, so then I have to convert that spline back to a geometry. Bam! Nice smooth line.
That's one way to do it. I was able to do the whole thing with one shot with P-Edit.
Yeah,
Mm-hmm.
this one worked out pretty good. I think I just had to break the elements so I didn't have any of the bottom returns, but then this is the finished product that we actually cut. So I mean, you can see
Looks
lines
good.
came out all nice. Yeah, left
Well, that's how
these
you
little
do that.
chunks in here as webbing to hold the sheet together while they put it in the frame. And once it's welded into the frame, they're going to cut all that out.
Oh, does the webbing have to be that big?
Probably not. I just didn't want to get any kind of bending on lifting and stuff. Probably could have gone down to about 1.5 inches. And
Yeah.
then these are all held in with tabs too, so that helps keep it a little more rigid as well. But
Yeah. Yeah.
well, man, I don't have to
That's
cut it
good.
out, so I don't fucking care. That's Joseph's problem. I told the salesman too, and I'm like, hey, this is gonna be a pain in the ass unless I can put a border. And they're like, no, no, no borders. The customer doesn't want that. I'm like, pain in the ass it is. Not my problem.
Sorry, Joey.
Not really. I don't care. He always tries to make my job hard because he doesn't want to do shit. So
Right?
gonna give it right back to him on this one. I was excited.
What was that one thing he was wanting you to do that he could have done in like 2 minutes?
Yeah, I had to do like what is it? I had to. It was like, oh, I want it done on the mill. That way, it's a perfect circle and they all line up right. Like, you're not capable of lining up two circles, Joseph. I mean, I can, but you just do it better. Well,
Yeah, I remember something. I was like, I can't believe he's. Why?
because your machine does it, so it's easier on me if your machine does it. Like, well, it's harder on me, dude. Well,
Right?
oh,
I remember.
he's always trying
I
to
like.
dish out his work to somebody else.
Yep.
He thinks he's the project manager. I'd be scared if he was a PM around here.
I wouldn't last. They're gonna give him more spirals, I think.
I mean, already all drawn out, and measured out, and all that other shit. All you gotta do is just mark out where
Build
to
it.
stick, where to stick everything. So
Just build it off the drawing.
I asked Jamie if he's taking Jamie. He's gonna take out that Reinke stair to go test fit. He's like, it's already test fit. Built it right there where it's supposed to be. Okay.
That thing's installed. You seen it?
The floating spiral, yeah. It's talking about the
Yeah.
other curve stair that I measured.
Oh, that thing.
Yeah.
Hmm.
He
Hope
said
he's right.
Said he's not test fitting it. He's just gonna send it. Like, okay.
That's scary.
Right? Yeah. There's a
I don't know.
lot of detailed points on our freaking drawing we took, so
Yeah. And it was a blend of a bunch of different shots. So if they didn't line up correctly,
been pretty obvious.
yeah. I mean, I felt good about it, but then again, every mistake I've ever made, I didn't know was a mistake.
Until
I
we
felt
get out
good
there.
about that too, right? Oh yeah, I feel good about that.
Yeah, that condition does
find out.
exist.
All right. And a Ranky stair, that turned out pretty good.
Yeah. I remember James showing me the original concepts for that stair. That was what, 3 years ago, something, 4 years ago almost now.
Yeah, 3 years ago.
Yeah.
Really?
Yeah.
Because I didn't see any conceptual drawings. I had to pick up where Neil left off with that.
Did I ever tell you what Dan told me about Neil? How he was
Uh-uh.
like
Oh, yeah.
called off a couple days and then Dan showed up to his house and he tried to figure out where he's at and opened the door, not closed at all. Like, Neil, where you been? Who are you? What are you doing here?
Wow. That's too bad.
Yeah. I'm waiting for my crazy to start coming out, running in my family. I don't know if I'm gonna get the dementia crazy side from my dad's at old age or mom's side's got a little schizophrenia or something. I might come a little early.
I think everybody's probably prone to something.
Right?
I'm already super forgetful, but I think that's usually, I think my brain will only hold so much. So when new shit goes in, there's shit that goes out. I'm just thinking about a lot of different things at the same time.
Right. It's a little
Gotta
weird to
slow
me.
down.
These drawings, like we drew the original panels with constrained numbers, but I guess it changes the variable number whenever we import the new drawing. I'm like, we
I did
created
not
a
remember.
created the pentagon with the constrained numbers and then import it to a different grid here and it changes all those constraints automatically.
This one?
Yeah,
This is drawing Robert created.
right. But our panel, even though we drew the original sketch with constrained numbers,
Oh, you're saying how they're applying?
yeah, I guess it figures out all the different points and then changes the constraints automatically in the background.
I don't know. How can that be?
Right? We've made a constrained drawing and now it's able to change shape and when you upload the element to a different. I guess
I'm
that,
still confused
right, I guess that's to do
on
with the
the
variable.
element issue. There he is.
What's up?
We're just talking about this. What do you call this?
I don't know.
It's pretty cool, whatever it is.
Camel wall.
How Marco was. What were you saying, Marco?
We make the original drawing sketch was all with constrained numbers. But I guess I don't know, I guess there's a variable formula too, right? When you save the element as constrained numbers and then you import it to this wall here, and it, I don't know, still changes all the numbers though. They're not really constrained anymore. Or is it just
That's
detects the
just
points?
for library. That's for library part.
Okay.
So
It's able to detect the points and change that to the new constraint numbers.
yeah, I think it's so something's happening in the background. So you got each grid area. So it's going to determine somehow it's going to determine the number of sides. So it's going to feed that into the INR, and then it's going to take each point from the grid and convert that into an IX and an IY value, and then those are input back into the variable list so that the facade is created in the shape that's desired. Now, how they make that happen, I don't have the first clue, but
I'm saying witchcraft.
Does it matter? Does it matter what plane it's created on, or does it apply to irregardless of what plane?
which plane the grid is created on, or which plane the panel sheet from Sketch is created on?
Oh yeah, that adds it even.
Yeah, so we draw the original panel on an XY sketch. I guess it just matters the work plane coordinate.
Okay, I understand. So I draw the panel on the world XY plane. So like it's on the ground and you're working on it. I know it'd probably be on its back if you were really working at it on the table or whatnot, but let's pretend that you're working on it from the front. So you're drawing it on the ground in the XY, because what is your grid? Even though your grid is being drawn on the XZ world plane, for example, it's still just an XY 2D sketch that's just turned up. So really, it's just an XY plane to prepare your panel part file, and then another XY plane just positioned in some manner, whether it's north, south, east, west, somewhere in between. Still just an XY. It comes back to all 3D is again just 2D. Again, it all comes back to everything's really 2D, just with a distance to it.
How'd you explain it earlier? You were like it would be just a distance off the paper, or one way or the other off the paper.
In or out of the screen. So if you're an AutoCAD person, you know, take that same part that you draw in AutoCAD and give it a depth. And do that however many times you need to get the shape of the part that you need. And you can remove too. Remember, you can add and remove material in 2D fashions. You know, there's some exceptions there. You got, you know, cylindrical holes or pockets, and probably more applies to machinery parts. But I think most of facade and cladding in general is still pretty 2D by the time you dive into it all.
Yeah.
Mechanical engineering is maybe a little different story, but all right. So did that exercise make sense? I think y'all seem to get it.
Yeah, I seem to understand, but I had forgotten the process of the
Saving the
adding it to
element.
the catalog. Yeah,
Yeah.
saving the element. So it's those kind of things I'm going to have to work on remembering and putting into, you know, repetition practice.
Sure. So even though this is a very interesting looking shape right now, nothing keeps you from preparing what we just did, changing it to a 4-sided shape. And let's say we want a 48 by 36 panel. Does I have to think about this? 0, 0, 36, 36. And it's going to ignore this one because this one only applies when you go to 5. So here is now your 38 by 46 panel, kind of like what we've done over here. And now take this right here and continue on like we started it. Just like we started it as just a width and a depth. You can do the same thing right here and forget about the fact that you prepared it to be all these different sides. Now take this and prepare it as far as you want to go for rectangular shapes. Just like what we're doing here. Because at a certain moment, you can now come back, you know, and say, okay, now I want to work on, you know, 5, or probably it could be more like 4, 6, and 8, right? Maybe some other shapes, but let's say you got a standard rectangle and you want to go around a window. So now that might be an 8-sided, or depending on the situation, maybe a 6-sided. Those are probably going to be your most common 4, 6, and 8. Probably. So it's like now, say you wanted to work on, oh, well, we didn't build this as 6. I'm sorry. That was stupid. So now you want to work on a 6-sided, you know, just change it to 6 and set up some kind of default situation here and continue modeling with flanges and miters and trims and, you know, whatever you need there.
Mm-hmm.
Make sense?
Yep.
Yes.
Okay, so I think now
One.
what should we do now? we need to add profiles, right? We need to learn how to attach parts to this panel and have it all behave properly. I'll let Marco finish his call. Now we can return to this panel and start adding, or we could work on this 5-sided. Actually, let's return to the square panel for this next part. Sorry, something just crossed my mind while I was sitting here thinking about it. I want to keep working on this one for this next part.
I think I screwed that one up.
Mine's a little funky, but I think it's good enough.
I'm not sure I even have that one anymore.
I have some weird miters on my corner, but
I can send you this one.
Yeah, that'll work.
we get all go off the same drawing then.
Yeah, remember, that's the one I screwed up.
I sent you a repaired file there, Barry. But
I have that.
But really, I'd like you to try to fix it yourself. And if you can't, you can give me a call. But I think you should probably try to follow the video. And if the video sucks, just tell me it sucks and we can look at it again. But
I didn't think it sucked.
okay.
I just gotta find it now. I know I saved it. Oh, that's the original docs. Where did I save it? It's called, oh, it's not new panel.
You had like a number in front of it, as the
Yeah,
part
I've got
number
that,
and
yeah.
underscore and like barrier or something like
Okay.
that.
Yep, I've got it.
But I just emailed you the one that we're looking at on my screen right now. So I don't know, maybe that's the best way to go to continue here.
All right, just got it.
There it is. You can save that in the XCAD transfer.
You want me to save it there?
Yeah.
Okay.
I'll pull it up and I'll look off the same.
It'll be in XCAD transfer,
And drawing.
iCAD. Then I'm going to save it here locally. So we're not fighting over the same file.
I got you.
So it's there in XCAD transfer.
I got it.
iCAD training. Panel. I'm going to rename this panel from Robert. Okay. Now I'm finna open panel from Robert. All right. Just how I would have made it myself.
It's not far from what you did, actually. All
Okay.
right. So let's look at this in standard configuration.
So you got top return 0.
Yeah, correct.
Okay.
Okay. So say we want to add a profile. We first need a profile. In your, please tell me I actually gave you the profile. Maybe I didn't.
What's the extension on it?
Got to put it here. Here it is.
Okay.
Go back to your 2D items where you have DXF files.
Yeah.
Or actually, we already saved this one, right? You have this in your catalog. Let's,
I think we
let's
did
look
do an
for it.
extrusion on it.
Let me open it up.
Profile.
Come on.
Oh,
So this guy,
I don't remember
I think-
seeing that guy.
I think we saved it as a library part.
Yeah, I think so. We did
You
the
can-
C
You
channel
can
and
check
then
and see if you have it here in your deal. And let's go look in the factory standard series example folder. And it's probably going to be a 1-100 something. I've got tons of them.
I have it in there.
Okay, well, good. So if this was a profile system that you didn't have, then you would need to import the DWG, take over the correct geometry, save that as a library part, and then
Yeah, I got it.
then we add it to our model like we're about to do now. Let's see. These are probably all the same for me. So let's say that we want to add this part, okay? Now, I'm actually not going to add it quite yet. I know I got a little ahead of myself. I wanted to make sure you guys had it in here. So I wanted to make some preparations because I think it makes it a little easier to bring it in. So I want us to look at this all the way back up here without any flanges or anything. Let's just look at our nice sharp corners.
Okay.
And I'm going to introduce you here to a command or a concept called a fitting coordinate system. A fitting coordinate system is basically a local series of points that can be used to attach other points. So we're going to relate these points to the panel, and then we're going to use these points to attach a profile to it. And doing it in this way, the part should correctly stay in its correct position, and then we can use some parametrics to allow the profile to adjust its length along with the panel as it grows wider, taller, whatever. So what I like to do, just watch for a minute, okay? Let's just watch. I'm going to create a local origin or a processing plane for this corner, for example. And we're going to do one of these for each of these 4 corners. So when I go to the next corner, I'm going to create another origin for here. So that way, all my reference points are related to the corner that I'm working at. And again, it's going to make more sense as you watch. So let's just dive in, and we can repeat whatever we need and answer whatever we need to. So I create an origin, a processing plane. And the command is here. So drawing ribbon, world CS, and then defined fitting coordinate system. Now let's, not this book. I'm going to pull up a book called USA Panel Step by Step. Now you can just watch if you want to. No need to open this up, but you're welcome to. This book goes through step by step. However, when this book was written, my colleague wrote it and I revised it at some point in time. Since then, I've learned better ways. So you can refer to this, but I'm going to show you the way that I do it now, which is simpler and easier, in my opinion. So, but what I want to show you is the concept that we're exploring here is going to be 3 points. We're going to put 3 points near each corner. 1 point is the origin. 1 point creates a vector in this direction. The other point creates a vector, in a different direction. So we're going to then use points on this profile to align with these points, and it's going to position it correctly and strongly into the parametrics so that things don't fly around on us. Notice that we're not using constraints here. You can use constraints here. It's far more complex. You got to alleviate all these degrees of freedom. And it's harder, messier, and more error prone. So we have this concept of fitting system points. So, okay, let's dive in further. So I have a local origin, and I'm going to call it the command. Now, this command is going to ask for 3 points: an origin point, an x directional vector, and a y directional vector. So here's where I like to use absolute points. So an absolute point is in reference to an origin, and that can be the local active origin, or it can be the world origin, depending on what's active. Right now, I have a processing plane here that's active. So right now, the local origin is here. Now, it might just so happen that the world origin is also there, but that's irrelevant. It's not active. How do I know the world's not active? Because you see here, local system active. When I hit W, now the world is active. When I hit this processing plane, you see how it switches. So world active, click, processing plane is active. So let's create some points. New system origin. I'm going to say A on the keyboard. A calls up absolute coordinate references. And I'm going to keep this real simple. 0, 0, 0. So point 1 is going to be right on the corner point of that processing plane. Okay. Point on x-axis. Absolute again, A on the keyboard. Let's make this simple, an x directional vector. Okay, third point. Any guesses?
It's going to be at the end of y. I don't think it can be a 0.
Correct. I'm keeping it simple here with 1 inch in each direction. Now this 1 can be anything. It's a vector. Remember, it could be 1, it could be 100, it could be 22.3, it could be 1,000,000. Now some of those would be kind of silly, but I like to keep it a 1 inch, nicely sets the points out that you'll see in a minute where you can visibly see it. It's not too close together, but it's also not like, you know, way out here somewhere. That doesn't make a lot of sense either. Now, why don't we see anything? Well, it happens on my computer. I have points switched off. However, when I click that on, we're still not going to see anything just yet. I need to take some additional actions inside this feature step. And to see this, notice that we have a layer number on each of these 3 points. Notice, here's point 1, here's point 2, here's point 3. When I click on them, they can become visible. So here's our origin. Here's my absolute 0, 0, 0. Here's my X direction. That was absolute 1, 0, 0. And here's my Y directional point, 0, 1, 0, that we did just a minute ago. But let's make these visible so we can see what we're doing. So I'm going to change this layer to a 1. I'm a little confused as why that's down there. Let's continue here. Okay, I didn't have the processing plane active like I thought I did. I'm sorry about that. So still wondering why it's not on top of the panel. Why? World origin. Okay, the mistake that it appears that I made is that I had the origin on the bottom of the panel, or I would like it to be on the top of the panel. So
I need to put mine on the bottom. Is that going to be a problem? Because I've always got like z equals 0, and then I build up from there. But you've got your top at z equals 0, as if you're building down from there. So everything you would build from there would the z number would be a negative number. Usually how I do things. I'll start off with a z equals 0.
Yeah. Is it because
and then build up. Well, I know when there's a negative z number, it's below my base. I noticed you're doing things a little bit different.
One second. I'm trying to figure out why. I'm going to take this away for a minute. Origin's on the top. That I don't like. Oh, here. Here. I'm going to say there we go. I changed the origin there. so that now my world and my part my base sheet are on top. Okay, so what did I just do? It was at the part level, and I had, similarly to the video that I showed you, Barry, here, instead of changing the assembly level, I said new origin for the new local or part coordinate origin. And the mistake that I think I made at the very, very beginning when we started this panel was that my base sheet, if you do a base sheet, it defaults. You see where the cursor is? It defaults to grabbing it from the bottom. If you do from Sketch, and here's one reason why I like Sketch a little bit better, is say I was to draw this from Sketch and derive this rectangular shape.
Z minus and Z plus.
Here you can set the Z minus, and look what happens. Now, well, it's easier when it's here. But
Yeah, right.
you see the processing plane for this sketch was set here on top.
Right.
Based on, you see the sketch. So here's our sketch. So you know that the processing plane was here. So one way I like starting sheet from sketch, even if it's a rectangular shape, do it from sketch instead of base sheet. I started with base sheet because I was trying to keep it a little simpler for you. Maybe I accomplished that. Maybe I just didn't, based on the little problem that we saw.
If we do base sheets, got to add the extra step of moving the origin.
Yeah, and do you have to do it that way? No, but I want the front face of the panel to be the 0.
Yeah.
And then work back from there. You don't have to do it that way, but that makes the most sense to me. And I think to most others. So, okay. So in case I haven't completely lost you here, I'm going to repeat my steps here for this fitting system. Maybe not bad to watch again anyway. So fitting system, notice where the active plane is, right there. It's kind of lying to us here for a minute. Kind of interesting. So absolute 0, 0. 0.2, 1, 0, 0. 0.3, 0, 1, 0. Now, once you've created this, you see how you can highlight the feature? It shows you exactly where it is. Sometimes I create this and I go to click on it here and I see nothing. And that tells me, oop, I made a mistake in my points. Either I was typing too fast or I mixed up the X and the Y, or, something probably silly mistake, but it can happen. So let's continue here. So here I have my points switched on, but I still can't see anything until I change this layer to one. You see the little tiny points appearing? Here's my X one.
Yeah, I see it.
Here's my Y one. So by default, it's layer 0 to kind of keep points hidden. So think of if we use this strategy for all 4 corners, and then your top extension for 2 corners, your right extension for 2 corners, you're going to have points all over the place by the time you're done. So to create it, you want to see them, but you might at a certain moment put these back to 0 so that your drawing doesn't have points all over the freaking place. But, you don't have to. It's just an idea. So here are these points. We can now see them. We have here something called point designation. So for, okay, a fitting coordinate system, and here's where I maybe type a little bit, type out some notes. I have to spell. Okay. So create 3 special points. Set local origin processing plane. Then use, let's say, A000, A100, A010. Okay, step 1. Step 2, fitting coordinate systems can have 2 functions. First is to set element installation origin if panel was not built on the world origin. So we've been doing this so that we skip this step. But let's say you build it somewhere else, you can override the world origin by defining these points, and that will allow it to come into element installation. I say just build it on the origin in the first place, and you don't have to worry about it. But let's leave that one alone for a bit, and let's focus on this second one. To attach parts to other parts, such as profile to panel. Example. So to use in this way, clear point designation numbers 1, 2, 3. I'll explain in a minute. Keep designation numbers 1 to 0. Okay. So look here. We have point designation numbers. So we are going to use this for option number 2. Maybe it would have been better to say numbers instead. Yeah, maybe that works a little better. So we want option 2. So we need to get rid of those numbers. So the software, when it reads those point IDs, it thinks this is what's happening. If it does not see those numbers, it thinks that this is happening. Bear with me. So let me go ahead and attach. Before I go deeper. This is kind of this makes sense in the end, but this is a tough, somewhat of a tough concept. Let me say I want to insert this profile. Let's see, series. I like to use this point as my origin or as my attachment method. Because this is the Carter system. So basically, this will wedge up in the corner. Yes, it's not correct right now. And it's going to follow the inside behind the two flanges. So I like to start with nice corners. And then basically improve from there. So let's give myself a little room to work. Because when you right click on another part, this can be a profile, it could be another sheet metal part we have here called define part placing. And the way this works is you're going to give it 6 points. You're going to align 3 points on this part to your 3 points that you created here. So here's my favorite way to do it. Here's where I say enter theoretical, and I'm going to calculate this theoretical point out in space here by using this line, and I want to assign it to that point. Next, I need an X direction. So I'm going to use the one down here. One reason why I kept this so small is so that I'm not having to zoom down here to the other end to select these points. Third one, align this to here, and watch what happens. It jumps to the position. So it is now living in this model per the relationship set up with these 3 special points. Now, this is not quite what I want. It's a good start. But I want, let's say I want this to align with the bottom of the panel. So here's where I can manipulate these points to say, for example, let's say I want this Z to be -4 millimeters. Notice that the point moved, the part did not yet. That's correct. Now the origin point has moved, but you see where these other ones are.
Yeah.
We need to do the same. Look at that. The X one slid down. Same thing here. Okay. That's going to help us in the Z direction.
Didn't you need to? Yeah, I noticed yeah, because you did that on the X and not the Z. It's
Did I
kinda
screw up?
crooked.
On point 30.
Yeah. You did it on the, yeah.
You are correct. Thank you.
You're welcome.
Okay. Nothing changes until you recalculate the part positioning, which is done at this part level. It does not adjust. So this is now actually pretty okay on the bottom of the panel, but obviously we can see it's not okay with relation to this flange and that flange. Well, we can utilize a similar strategy here.
Okay, I see. So you would just, that's how you're
Actually, I want
offsetting.
positive. Positive, I'm sorry. You see the positive? Look, it starts here and goes that way. So I want positive
Right.
4 and positive 4. What did you just do? I just collapsed everything. Sorry about that. Okay.
Yeah.
Same for the, let's see. Yeah, perfect. So what I need is this is just a vector. So here I want 4 Now that's sitting pretty nicely, actually.
Yep.
Now, there's actually there's an easier way, but I want to show you this full concept yet. I'll show you an easier way on this one. So now what? So now, this thing's looking a little short. Well, here's the length. What value do we already have that exists that we could either relate very easily to the length of this panel?
IL.
IL. I of L, and to make it exact, we then want to say minus 4 millimeters times 2, so that it's you got 4 on this side. The thickness of this flange, yeah, I screwed it up. 4 on this side and 4 on the other side. So if I say minus 8,
didn't you already minus 4 on this side when you did the offset?
Yeah, but to be protruding 4 millimeters through
I'll
could be
show
already
you.
adjusted. Yeah.
So you're already 4. You're 4 in here,
Okay.
and that has to do with the offset.
I got
points.
you. I
So
got
down
you.
here, if you say
you're
minus
referencing
4,
IL. Right.
it's only half as much as you need.
Right. It's because of your reference IL. Yep.
Now, you might want more than 4, but at least you see how the concept is. If you need more clearance, that's fine. Put it in there.
Right.
All right. Did I miss anything here? I don't think so. Now, let's say sometimes you use 3 millimeter material. I can show you more advanced parametrics where it actually takes the thickness of the actual catalog material. But let's table that for just a little bit here. Let's work on this concept first. Okay. Questions, repeats, what would help you? You want to just try it?
Yeah.
Yeah, I'd like to try it. I understand it. I'm just remembering all of the procedures. So basically, you got to create. You're going to do this 4 times. Bet you couldn't do it twice and just mirror. But anyway, we're looking to do this 4 times.
4 times on this base sheet, and you might need to do it again on your extension returns. I don't have a good replication because the way the feature step works, the edges in the local origin is captured uniquely in each feature step. So if you were to copy that feature step, don't
right,
think
it would have to have
so well.
It would have to have a unique identifier, is what you're saying. Even though you would have like a mirrored function, it would still have to be identified uniquely.
You can clone a feature step, but it creates like a pattern. That's not really what we want here. So,
right.
Excuse me. So, my answer is we have to do them one at a time.
Good answer.
I had somebody, now I get it, this is a little advanced, but I had somebody just told me flat out no. Like I explained this to him, and he said, no, show me a different way. I said,
really?
There is no different way. This is the way. He goes, no. I go, what do you keep telling me no? He goes, I want to know a different way. I said, okay, I'm sorry you feel that way, but I was shown this way. by somebody with 25 years of experience in this software platform, and he tells me that this is the way. So I could put you in touch with him if you want, but he's going to tell you the same thing that I'm telling you right now. This is what you got to do. I'll work through it with you as many times as you want.
It's not going to work another way. I mean, you have
he's a unique
to.
character. He's actually doing very, very well, but
Good.
there are some little issues during training. Let's put it that way.
Okay. So I'm already thinking that your screen was mine. I'm getting ready to move over to the other corner. When really I haven't even started this yet. Anyway, yeah, I'm getting tired.
So let me see.
See what
Let me
happens.
finish this. So we got.
Yeah.
So clear designation numbers.
We're gonna
Or
mess with you.
part-
I'm just gonna say no. It cracks me up. No, Robert.
I was like, this is it. This is it, man. I'm sorry.
The end of the line.
Part positioning, or is it part define part placing? Okay.
What?
Where we'll ask you for 3 points.
So there's a similar function in AutoCAD, which is probably why I understand it really well, where you can use 3 points to define your, I don't know what you'd call it, temporary coordinate system to create, so you can work on any plane.
Yeah.
You can use geometry to reference those 3 points, or you could use an orthographic, as long as you reference something in the geometry, you just need 3 points, and then that's going to define your X, Y, and Z, or your X and Y and your Z.
Yeah.
And it's always left, right, and then up. You start at origin, you go right for your X, and then you go up to define your Y. And then your Z is implied from there, which I've used rather frequently when I'm doing 3D work.
Fine.
So you could basically do this on any plane to create
And that's why I create that processing plane before I call this up, because if I was to do this corner here with this current processing plane, yeah, I could do it, but I would be doing crazy math to relate this corner back to this one. Okay. I will send you this. I don't know if you want that now, or so you got something to look at, or if you want to take a screen image of this right this second.
Take a screenshot.
But I will send you this by the end of class today, so that you can either add it to your notes or use it to create your own notes or whatever you want to do. And how about this? I'm going to delete this. Get rid of this fitting system. Delete the profile. And let's do it again.
Oh, that's right. We gotta bring that profile in.
Let's start with the points. So you have a processing plane ready to go?
Yes. Oh, processing plane? Maybe not.
You can grab it right here.
Okay. All right.
Okay. Make sure you click the processing plane just by clicking on it. Make sure you don't see the globe. So no globe. We want to see this. So just
On the
click
green.
once. Just click once on the green line. That's all. And let's call up this command.
Define fitting coordinate system. Okay.
So origin. So what's a good origin point for this local this processing plane that we just set? How about keep it easy? I hit A on the keyboard.
Okay. 0 space, 0 space, 0. Okay.
Okay. What's it asking for next?
X.
Point on X axis.
Okay. So hit A again.
0 space, 1 space, 0.
That's why.
This is X, so 100. Or is that what
That's
you
what I
said?
meant. Yeah.
Okay.
No, that's not what I said. That's what I meant. Okay. Now point on Y axis. Press A again for absolute. It would be 0 space, 0, no, 0 space, 1 space, 0.
Okay.
Yes. I don't see it. Oh, there it is. Fitting
Finish.
coordinate system.
And if you click on it here, highlight the feature
see it up
step,
there.
hopefully you see a little orange access indicator.
Yep.
I don't see it on mine.
You don't see it?
No.
Okay. Can you share, please?
Yeah. Don't mind this one. All right. I got a point,
This is that.
and a point. No arrow.
Okay. Something. Yeah. Okay. So you see down there on edited part, a little bit further down in the feature step,
Yeah.
you see that it's the sheet flange. This I did not say. You don't want to select the flange. You want the sheet to be the active part. So
let's just delete this out.
Sometimes you can clear out that instead, but sometimes it also doesn't work. So activate that and now call it up.
Okay. We're gonna do plane, select.
Let's see. I'll add that to the notes.
Hey, there it is.
Activate sheet
Part.
metal main part. Not sheet flange. Okay, I'm just adding to the notes here.
Mine's going the wrong way. I'll share my screen when Michael's done.
Yeah, you're good. You can share.
Let's see that. Okay, in this case, instead of deleting it and starting over, let's see if we can repair it without. So let's look at these points that we need to expand a few times here. So origin looks okay, but let's look at that. Show me your processing plane, or is it already gone? Okay, you see which way your processing plane?
Yeah.
The processing plane does not have the X going left to right and the Y going bottom to top.
So it's
now-
matching the processing plane, but I
So-
should have started on this corner over here.
Well, no, you let's see, to put it bluntly, just pay attention to the direction of your processing plane. Don't just slap it on there. You know, dance your cursor around until it's going the way you want it.
Okay.
Now how to repair this? You don't have to delete it. Go ahead and delete that processing plane that you have just by right-clicking on it. Let's go ahead and just get rid of it. So yeah, delete all planes. That's fine. We only have one. So in this case.
Okay.
Now, over in your feature step for fitting coordinate system, almost all the way at the bottom, you see processing plane? Down, 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 down.
Down here?
Yeah.
Yeah. Now, double click on that in your feature step. Now, set a new processing plane and pay attention to the directions as you.
Yeah.
That's what I thought I was doing from there.
Yeah, fair enough. Fair enough. All right. Go back to your. Click on your feature step for the fitting system at the very top. Let's see if we see. See, now it's going the right direction. You didn't have to delete it. You didn't have to start over. You just edited some things in this feature step that was already there.
Okay.
Sometimes the first tendency is to blow something away and start over. And sometimes you do have to do that. But
Yeah.
often enough, you can edit and repair what's already there.
Okay.
Okay. So that was step one. So we activated, I added to the notes here, we activated the sheet metal part, not sheet flange.
Right.
We created these points, and now we're going to come down to here. This is mainly just to understand that since we're using it in this way, we need to clear these numbers. So basically, if we're using it in a different method, it needs these numbers to function. Now, I would like to see when we call up this command, a little dialog pops open and says, you know, are you using it for this or this in some way or fashion? And then you can make a selection and it either keeps them or clears them automatically. I think that would be clearer, but that's not what we have right now. I'm sorry about that. So at the moment, we need to know that for what we're doing, part positioning, we need to highlight. Again, I can hold Control, select all three, right mouse button, and get rid of those designation numbers.
Point designations, highlight all three,
All three?
and just
Yep,
clear.
just clear.
So the points remain. They just don't have a designation.
Correct. The points are just not numbered. This command does not need those numbers in the background.
Okay. Because we're going to do this on all four corners, right?
Correct. Yeah, all these steps will be replicated on all corners. Okay. I skipped something here, so let me add that. Set points to visible by changing, what is it, layer? By changing layer from 0 to 1. So there's not a way to select all and change them to 1, so we got to go one by one here. No. If you change them from 0 to 1 and still don't see the points, speak up.
I'm seeing it.
On the bottom. Got him.
Okay. So next step. Now we need that profile in there. So insert profile if haven't done so already.
I have not done so.
So here's another reason why I create these points before I bring in the profile, because these points are great to snap on to insert this profile. And I like to do the little nub because it makes it easier to set everything up and then extend it to the right length. So we go to steel, beam, and we got to go find it. So
100.
in order to find it, this is quite a bit going on here. So usually what I do is I start here. I collapse all because we want to be in factory standards here because this is a user created profile, let's call it. So if we were adding standard I-beams and tubing, that's what we call hollow profiles, flat steel, whatever, you would be in semi-finished. But we want to be in factory standards, series, and then example. Maybe I'll write that down. So insert profile. So collapse all. And factory standards,
Series.
series, ISD example, or whatever table you saved it in. It could be different. And find profile. Here, I'm going to save these notes. Okay. So can you find your profile?
Yeah.
Do you see it? Okay. So I'm gonna double click, and here's where I don't know what point is active for you right away. Maybe the middle. Here's where I like to change it to this corner. Now that might not be the case for every profile system, but for this particular one, I think it makes sense. So here, remember how to place the profile. Here, I'm going to give it a start point and end point. And here's where I just say origin to X here. You should get a preview. And this particular profile, we actually want it to be flipped. Here with the little switch ends, you see how it then dances. We want it. We want the teeth going out because a rivet or a fastener goes in here. It's supposed to be like drillless attachment. This is like this system's claim to fame or whatever.
So how do you flip it?
Switch ends, these little arrows.
Oh, okay, I see.
And once you're good with that, you can middle mouse or OK.
Okay.
All right. Now, a couple of things. At least looking in my structure, this is not inside the panel. You see that?
Yeah.
So we just need to
Drag,
drop.
It's not showing underneath it, but when I drop down my menu, it is.
Say again?
But mine doesn't show up automatically. You have to pull the menu down, and I start seeing mine. You drag and drop it again. Kind of show me how. I do wrong. I'm on assembly.
So say it was up
Oh,
here.
you went all the way. Oh, hold
So
on.
say it's just basically in this drawing and no really other structure. You just drag drop into whatever you called your assembly.
Gotcha. I was dragging it on the sheet metal panel.
Oh, yeah. That
Not good. Got it.
probably wouldn't work so well in the end.
I got it right now.
Okay. So now all we did was just threw it in here. We just happened to snap to these points. The fact that we clicked these points did absolutely nothing other than just putting it in the drawing. Okay. Now here's where I want to give myself a little room to work. So I usually say right click, transform in a direction. Here's where I just click this edge. And because the arrow is going the wrong way, I just give it a negative value and I just kick this out a little bit. I used 4, I don't know, maybe 2 would have been good enough, 3, whatever you want.
You did transform move part?
Yeah, in edge direction.
Okay.
Okay. All right. So we added our part. We need to now define the part placing. So right click on the feature step. Here, let me be clear. Let's see. Right mouse button on part feature step, not structural. Not part structural. We'll make this as clear as we can. Okay. So define part placing. Everybody there?
Under activity, yeah.
Okay, now it's going to ask us for, remember, 6 points. 3 points on the part and 3 points on the panel, let's say, and it's going to alternate. So point on the part. And this is going to differ from profile to profile, right? You need to figure out what works best for the profile that you're trying to attach. Right now for this one, I want this theoretical point right in the corner of this panel. So how do you calculate a theoretical point?
Just guess. Get close. Mine is red and yours is not. Why is mine red?
Oh,
There we go.
because that drives me crazy sometimes. So if you don't actually have the feature already highlighted, when you do this, it's going to be red. But you see how where I click away and I right click without it already being highlighted, then it doesn't turn into this obnoxious orange that makes it a little harder to select points and edges.
Okay, so define part placing.
Okay.
Mine's still red, by the way, but
okay,
it'll work.
Share your screen. I'll try to. I know it's kind of obnoxious, so I'll try to show you what my trick is.
Yeah, it's obnoxious. I tried to.
All right, click in your drawing area. Just once. Okay, you see how your feature step is not highlighted?
Right.
So try a right mouse button on it now.
On this one?
Yeah. Damn.
Define
Okay.
part placing.
What am I doing that's so special then?
Do you have it turned off in your system? You showed us that earlier. Like a little preference.
Try it again. So middle mouse to end the command. Okay, click once in drawing space to kind of unhighlight it. Okay. Now go up to the feature step again and just right click. I don't know why it's working for me and not you.
Might be something you turned off at some point. Maybe you don't remember.
I don't think so, but I do recall that sometimes I can't get it to not be orange, even though I try.
Okay.
Well,
this is our original. Yeah. Okay. So we right click here, define part placing. In SolidWorks, this would be locate profile. We would just click here, right? And then find a spot on this origin right here for that. And then it's asking for 0.2 on the part, which we would go, I guess that's a point.
That is the access point. Okay, here's my statement on using access points.
So I could be grabbing anything around there, you're saying?
Let me explain. So those profile accesses can be switched on or off. Now, that being said, as long as you don't switch them on and off, you're not going to have a problem with the parametrics. But if you were to be in your model and suddenly you want those accesses to be switched off, now your reference point fails and your profile may be unattached. So it is my standpoint that let's not click on those system accesses. While it's very convenient, let's actually calculate that theoretical point using 2 edges on the part instead.
Okay.
And that's my advice. Take it or leave it.
Okay. So then I would zoom in here and just select an edge like this one.
Remember, how do you calculate a theoretical edge? You need to
Enter.
you need to call up that command. So you got to go to enter
Press enter.
and
this
find
one?
the one. There it is. Now give it 2 edges, and here's where the orange glow becomes a little obnoxious. But if you zoom in there, you can actually select. You can indeed actually select. I wouldn't. I would pick that one. Well,
and this one.
Either one there should get you the same place.
Okay. So now we got to do a point in the drawing.
Point in the drawing. We'll find out soon enough if your theoretical point was good or not. Did you click and zoom?
I accidentally clicked and held it. Point in drawing. Okay, here we go.
It gives you another chance. Well, that's good.
Right there. Second point in part. Another theoretical.
Yep.
Which would be, how do we get there?
Enter.
Oh, enter. Right there. That one and that one. Now click a point in the drawing. We want there.
Yep. Now, a minute ago, were you selecting an edge, or did you select midpoint? You think?
I selected the edge.
Okay.
I didn't see midpoint come up. Did you?
Oh, it popped up there at the end, but probably just because you moved your cursor over a midpoint somewhere. Okay, this last one's easy. You know, you don't have to calculate a theoretical because you got a nice corner that's going in the right direction.
So it would be this corner right here to that point right there. Yep. This is a lot like the align command in AutoCAD is very similar too. This part. Setting up the coordinates is different, but the align command in AutoCAD isn't as deep where you can't, or at least I don't know that you can do a theoretical point like that. Or to create to create a theoretical point off those 2 edges. I think that's really cool. I'm gonna have to remember that.
Yeah, there's a lot of good point options in that enter key. Probably just start clicking on them one by one. There is actually a help page in the wiki that will go through all those. We could find that quickly. Let's see. Overview of point options. That sounds good.